Good morning. My name is Stuart Halloway, and welcome to QCon. I'm going to be talking to you today about Clojure Java Interop. I am not going to spend much time getting started because we have a lot to do. How many people have seen Clojure before? Just a quick show of hands. Almost everybody. Let me move from there to how many people have written a couple of lines of Clojure or more in the past. Okay, now we're down to about a third of people in the room. So we're going to talk very briefly about syntax. I don't want to spend time or get lost in that, but you need to be able to read it if you're not familiar. And then we're going to talk about the plumbing. Right? This is the JVM track, and it's about mostly about languages and interop. And so we're going to talk about Clojure calling Java. We're going to talk about Java calling Clojure, and we're going to talk about objects the way Clojure sees them, which is different from the way you're used to seeing them. That's really all plumbing, right? It's mechanics. It's how does this talk to that, and how do these things fit together? And it represents most of what I normally cover in a talk like this. It also represents most of the questions I get asked at the end of a talk like this. They're specific things like, I have a widget and I need to stick it to a grommet, and I know how to make that work in Java, but how is it going to work in Clojure? Or how is it going to work in JRuby or Groovy or Scala or anywhere else for that matter? I don't want to spend the entire talk on that, though, so I want to talk about design principles as well. These are design principles that inform the way Clojure approaches interop, and I think they're distinctive. And so one of the things that you're going to see today is that there are a lot of great languages available on the JVM. And I think there are a multitude of reasons for that. Maybe some of those will get discussed as we go through the day. But regardless of how it happened, it's now true. And so you have a lot of great choices. And I want you to come out of this talk today knowing where and when Clojure might be a good choice. Not on a superficial mechanical plumbing level, right? This connects to that. It's not really that exciting, right? All these languages can do that, but at a conceptual level. So, syntax. This is pretty simple. We have strings, which are Java strings. We have characters, which are Java characters. We have regular expressions, which are Java patterns, java.util.regex.pattern. We have integers. We have arbitrary range or arbitrary precision integers with the n suffix. We have doubles, arbitrary precision doubles. They all, again, correspond to things in Java directly, long, big integer, double, big decimal. We have Booleans, which correspond to Java Booleans. We have nil, which is the Lisp world way of saying null, but it corresponds to Java nil. We have ratios, which Java does not have, but you can imagine how they work. And if you've worked in a language that has a richer numeric tower, you've had access to a ratio class. And they're available as literals. With symbols, which are names that the language is going to go and look up. They're going to mean things, point to things in code. And we have keywords, which are names that are kind of more for your use, right? So if I want to create a map and have some keys and values in it, I might use keywords for those. Two observations here. The first one is that when I say that the Clojure things here unify with the Java classes or primitives in question, I'm not saying that the Clojure things wrap those things, or that the Clojure language provides alternatives to those things, which are magically swizzled by an interop layer back and forth. I'm saying that those things are, in the strictest sense of the word, those things. Right? So if you're coming from a Java background and you run into one of these things, it's going to be exactly that thing that you know from Java. Clojure has 4 data literals. A list represents conceptually a singly linked list, something you would insert at the front of and is in parentheses. So open parens 1, 2, 3. A vector is a random access collection by index, and insertion is conceptually at the rear, so in square brackets. A map is a collection of key value pairs. So here I have the keyword A and the value 100, the keyword B and the value 90. Those might be grades. This might be a translation table from grades to numeric grades, for example. And we have sets, and the set literal is the pound sign in front of the curly brace. We ran out of different kinds of punctuation that looks like that. So the pound comes into play, and that represents sets in the mathematical sense, right? Uniqueness. A couple of points about these data literals. The first one is they can be composed of anything. Everything nests with everything else. Right? There is no limitation anywhere that says you can't put an X inside of a Y on a Tuesday when it's raining. Right? All of these things nest, and Java things can be dropped in as you see fit as well. Here's a hello world program in Clojure. It's It's a function call, so println, the function, and the argument's a single argument function, which takes a string. In this particular case, a single arg. You'll see that because this is a Lisp dialect, we have the parentheses on the outside. So the open paren comes in front of the beginning of the entire expression, not after the name of the function call. Notice also that while semantically this is a function call, how much syntax did we add over and above the syntax for Clojure's data structures, which you saw on the previous slide? None. People say a lot of misleading things about this. People make claims like Lisp has no syntax. That's going to be rough, right? If you have a language with no syntax, it's going to be hard to say anything. A more accurate thing to say would be that Lisp has the syntax of its data structures, and that syntax is then built upon to write code. Right? So here we have the interpretation across the bottom, a structural interpretation, interpretation across the top, a semantic interpretation of the same data structure. That was calling a function. Now I'll show you defining a function. So defn defines a named function. Defn is itself a form that takes arguments. It takes how many arguments? Count them up in your head. 1, 2, 3, at least 4 in this case. Right? So its first argument is the name of the function. Its second argument is a documentation string. Its third argument is the argument list of the function being defined. Its fourth argument and subsequent arguments, if there were any, is the body of the function. So notice again that we have defined language stuff, but it's all just made of data. So defn is a symbol, greet is a symbol, returns a friendly greeting is a string, the argument list is a vector, and the body of the function is lists. The last little bit of syntax that I'll show you is reader syntax for adding metadata to a thing. So Clojure programs are read by a little piece of code called the reader. And the reader reads these data structure, reads this serialized form of this data structure, the thing that you would type at the keyboard, the thing that you're looking here, and converts them into Clojure's data structures internally. While it's doing that, Clojure has a first-class notion of metadata. So metadata is a map of information that can be applied to other bits of Clojure data. So here, the greet symbol has the metadata string on it. Now, there's a couple of shortcuts going on in this particular example, and they're quite common. I said that metadata is a map of information, but string is not a map here. What is it? It's a trick question. It's the word string, but what data type is it? Class. It's a symbol before it's a class, right? At read time, it's a symbol. Eventually, it's going to be resolved to a class, but it's not a string, right? First it's a symbol, then it's a class, and then if you instantiate it, you'd actually have a string. And when you have just a symbol like that, then Clojure says, oh, you must be building a map of type information. Right? We're going to be doing type information here, so that's going to expand internally into a map tag string. But that thing after the caret, anytime you see a caret like that, that's going to be a map of information or some shortcut form that creates a map of information. And that map is a first-class thing. Right? It's a regular Clojure map, so what can it have in it? It's going to be a recurring theme today. What can go in that map? Anything. How deeply can it be nested? Any arbitrary depth. What rule comes into play on next Tuesday when it's raining that stops you from doing something? There is not such a rule. Now, let's look at Clojure calling Java. So here, I'm going to show the Clojure syntax in parallel with the Java syntax. If I wanted to create a widget in Java, I would say new widget and then pass in the argument. In Clojure, I would say widget dot. A dot is a syntactic short form that's part of the symbol, so that actually becomes the symbol widget dot to Clojure, but then that gets magicked into make a new widget. Accessing a static member. In Java, you'd say math.py. In Clojure, you could say math/py. Calling a function. In Java, you could say rand.nextint. In Clojure, you're going to have the verb first, so the function first, then the object that's being called on. So instead of rand.nextint, you have .nextint rand. Why does that matter? We're going to see the benefit of this later, but I'll go ahead and start to underline it now. Lisps, and Clojure follows in this tradition, have an incredibly regular syntax. Open parentheses followed by, and I'm going to call it the verb. Right? If it were a human language, right, every single sentence begins with a verb. Now, it's worth noting that, Clojure is a primarily functional language, so you might make the superficial argument, well, oh, it's a functional language, so we're going to elevate verbs, they're going to come first. But does the noun always come first in Java? Not at all, right? I mean, Java's all over the map. Right? There are a bunch of different ways in which things can happen. Sometimes this is first, sometimes that is first. So the goal here is to have one rule that's in play at all times and have everything be completely consistent. Now, let's say that you were building an application where you needed to access a piece of data inside a piece of data inside of a piece of data. Some people would call this a law of Demeter violation. I'm not going to call it that, but I'll point it out because just in case somebody wants to raise their hand and complain about it for that reason. But people do it. And in Java, I might say person.getAddress.getZipCode. Or I might say person.getAddress.getHomeAddress.getZipCode. Right? This can go to an arbitrary length. And in Clojure, the way I would say that is the ... form. The ... form says I'm chaining together a bunch of calls to Java. So do this, and then do that to the result, and then do that to the result, and then do that to the result. Intriguingly, which of these forms has more parentheses? So if people ask you why in the world you burned your first talk at QCon learning about Clojure, you can say, well, I really wanted to get away from all the parentheses in Java. I'll show one last form, and this is a convenience form. It's not used terribly often in Clojure, but it demonstrates some things that I'll talk about later. Due to. Right? In Java, it is quite often the case that you instantiate an object and then do a bunch of things to that object to get it in its right state. And Swing is a perfect example. Right? I want to make a frame. I want to add a proxy JPanel to that frame. I want to set the size of the frame. I want to set the visibility of the frame and then turn it loose. And so due to is a little bit like ... but if you go back and look at ... what does ... do? ... says take the result of this and chain it to that, and then take the result of doing that and chain it to the next thing. Due to doesn't chain at all. What does it do? It creates a first thing and then makes it the argument of all the remaining things. So this says due to a frame X, Y, and Z. Why would this be less idiomatic in Clojure than the thing on the previous slide? So, Ryan.
Because one of your parameters isn't immediately visible inside the function list?
That might, I think that's a syntactic consideration. I think the bigger consideration here is that due to implies what about the object underneath? That it's immutable, right? That I'm going to do something to it, right? So, and we'll come back to why we allow this at all later, but Clojure is a primarily functional language. Right? Clojure is a primarily functional language with a really powerful story for time and concurrency and parallelism. And that's the primary story that a lot of people may be interested in about Clojure. I'm going to say nothing about that story today. Right? Not a thing. I am giving a talk on that story on Friday, talking about the concurrency and parallelism piece. So if you're interested in that, come on Friday, or if you have conflicts with that, grab me after this talk, and I'm happy to have a one-on-one or three-on-one or whatever conversation about some of those issues. But we simply don't have time to talk about it here. I'm just going to mention in passing that except for due to, right, most of the stuff we've seen so far is immutable. The data structures are immutable, and there are all kinds of implications to that that we'll talk about on Friday. I won't beat on the parenthesis thing anymore. So, really quickly, how does working in a language like Clojure change from working in a language like Java? When I started explaining Clojure to people after I had used it for a while, I decided that a good way to go would be to take idiomatic Java code and show what that would look like in Clojure. And so here we have that most idiomatic of Java code, something that comes from the Apache Commons. And I know, maybe that's not fair, but certainly a lot of people, how many people have this Apache Commons jar somewhere in a project, right? We all depend on it. This is enterprise quality stuff, whatever that means, right? So this particular implementation wants to tell me if a string is blank. And it turns out that from this perspective and in a lot of application scenarios, a string is blank if it's null, or if it's the empty string, or if it's full of what? Space, right? If it's full of white space and tabs and whatever. Because I don't want somebody creating a user account on my system that's space, 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 tab, tab, backslash, in, backslash r, because it's going to confuse the heck out of everybody. So here's how the function works in Java. I mean, basically, it checks the corner cases, and then it has a for loop, blah, blah, blah. We're going to convert it into Clojure. I'm not going to spend a lot of time on this. We're going to go really fast. I'm going to get rid of the type declarations. I'm going to get rid of the class. I'm going to introduce a higher order function. I'm going to get rid of the corner cases. And I'm going to switch to Lisp syntax. When I'm done, I now have a function that is named differently. So the Clojure naming convention's lowercase, blank. It wouldn't be is blank in Clojure because question mark is a legal character in symbols, and so we use that idiom often in the dynamic languages of going blank, right? So instead of saying is blank, which feels like sort of it is blank, it must be blank, right? It's a question. The argument s is presumably a string here, and then every is another one of those predicate functions like blank. So every is a higher order function. Every takes two arguments. Its first argument is a function. Its second argument is a collection of some kind, a sequence of some kind. And every will return true if that function applied to every item in S returns true. And as you can imagine, there are a bunch of other functions like every, like any, and not every, and so on and so forth that cover other scenarios that you might care about. Ola has a question.
So if S is null, that's treated as if S was an empty list or an empty sequence?
So Clojure allows you to pun with nil quite a bit, and I'm a big fan of it. It's not a requirement. The idiomatic Clojure style guide does not actually say write your code this way. I like it. If you don't like it, you won't be kicked off the Clojure island. But I do like it. So in this particular case, nil will do what I think is the right thing, right? Which is originally the contract for blank, right? That nil would return false. And so from a logic perspective, if the collection is empty or if it is non-existent, if it's nil, then everything in it is white space, kind of in a degenerate way, right? Because there's nothing in it at all, or it doesn't exist. A couple of things worthy of note here. First off, how much Java interop is actually left once I reduce that 12 or 13 line Java code into a Clojure code? How much Java interop is there still here? There's 1 bit, right? Character / is white space. And you'll see that, and in idiomatic Clojure, it's perfectly fine to have Java interop sprinkled all over the place. But usually it's sprinkled and not poured, right? You don't end up seeing a ton of it because you build out of higher order constructs like every. The pound syntax in front of that character is white space is the shortest, most terse way in Clojure to say give me an anonymous function. So pound says give me an anonymous function that takes an argument, and we're not going to make you specify the name of the argument every time because that would make the form longer. So what's the name of the argument? %. And you can, in fact, go all Perlish. You can even do %1 and %2 and so forth if you want to. That quickly becomes non-idiomatic, and you will get kicked off the Clojure island. Right? If you do this for a longer function, that would be bad style. But it's nice for a short function. Now, that's the side of the story that I normally tell about Java interop just in an intro setting when we're about to now make a left turn and dive into all kinds of other things. Here we're going to make a right turn and dive into OO done Clojure style. And so we're going to look at, first, a thing called records. So in Clojure, you have a form called def record that instantiates a thing called a record that has named slots. So here the record is named foo, and it has 3 named slots, A, B, and C. And it returns user.foo when I type this in at the REPL. By the way, almost all these code snippets are as if I had typed them in at the interactive REPL. Right, so I'm interacting dynamically with the system. It's a dynamic language, right? I'm not compiling and going through a lot of steps here. And the little arrow, the minus arrow, is my sign for, and here's what the REPL says back to you. Right? The Scratch namespace in Clojure is user. So anything I create is automatically in the user namespace. What do you suppose namespaces in Clojure map to in Java? Packages. And how complete is the mapping, given what I've said so far? Right, this is going to be a theme later, right? It's direct. It is, in fact, the package. So this user namespace in Clojure is the user package in Java. And foo, you're never going to guess if you looked at it in Java, what do you suppose it is? It's a class. Right? It's called a record in Clojure, but it is a class. It has a positional constructor. So Java has positional constructors, right? The argument order matters, not you don't have named arguments. Ditto for records in Clojure. It has a positional constructor. So this says define me a top-level thing called f, and make it be the instance of foo where I pass in 1, 2, 3. And remember that foo dot is the syntax for instantiating a Java class. Records are Java classes, so we can just leverage that. I can get things out of that with keywords. I could also say, by the way, .bf. Right? So .bf would be accessing the field directly. Right? That's raw Java interop. But I can also say keyword access :bf. Give me that by keyword lookup. And I can ask what the class is of f. And if I looked at the class hierarchy of f, I would see a bunch of stuff. And basically what all these are interfaces for the most part, basically what these interfaces add up to is that set of services that are available to all records and to all data things in Clojure in general. And the mission here is generic access to data. Right? When you create a Java class, when you're first building a program and you create a Java data class, what is the number of Java clients in the world that have been written against the API you just created? By definition, 0. Right? You just wrote, every time you write a new Java class, you just wrote a private language for accessing data that nobody else has ever seen. And then they have to go and write code that uses your private language for accessing data. This and this are a refutation of that idea. Right? We don't want to have a private language for accessing data. We want to have a general purpose language for accessing data. So when I create a record in Clojure, it's immediately accessible as data via keyword lookup. And it has Java's interfaces for collections, iterable, and somewhere in here, java.util.map, java.lang.iterable. So this is already a Java collection that exposes all of its internal data. And then it has Clojure interfaces for collections, which are, we won't go deeply into this today, but they address limitations in the Java collection API and provide a more granular approach. You'll see there are more Clojure interfaces here than there are Java interfaces. That's because the Java API is, the Java collection API is one of the best designed things in Java. Nevertheless, it is still insufficiently granular. And so there's a need for doing the things that we want to do in Clojure to have more granular interfaces as well. Here's a piece of data. It's a map that tells you about me. First name Stu, last name Halloway. Address is a submap. My street is 200 North Mangum. My city is Durham. My state is North Carolina. My zip is 27701. Having built data like this, I can access via a keyword. So the last name of Stu, looking up into that map, is Halloway. I can also do nested access. So I can say, take Stu, get the address, get the city of the address. So go up to the address, 200 North Mangum, get the city, Durham. So that little minus arrow sign there is called the thread first operator in Clojure. If you're coming from a Java background, you might also read that as the magic convert Lisp from inside out to left to right operator. Right? Because a big difference when you're coming from a language like Java to a Lisp like Clojure is that a lot of things read inside out. That's not mandatory in Clojure. You can make things that read left to right anytime you want to with the thread first operator. Right? So the thread first operator says, go to Stu, get the address, get the city. What other operator does this remind you of that we saw earlier? The dot dot. Right? And the dot dot, some people actually wanted the dot dot deprecated out of Clojure when the thread first operator got added. But the dot dot tells you more. What does it tell you you're doing specifically? Java interop. Right? So there is a communication advantage to dot dot if you're trying to tell your reader, I'm threading Java interop versus I'm just threading arbitrary pieces of code. Now I'm going to show you an update. So a soch takes a map and a key and a value, and then it replaces that key with the new value. So a soch Stu, fname of Stuart. I'm tired of people calling me Stu. That's a corny nickname from college. I want to be called Stuart now. So a soch Stu, fname Stuart. Now, does that actually change the original collection? No, right? This is all immutable. I'm not, again, this is the last time I'm going to say it. I'm not talking about immutability, functional programming, identity, state, and time, all that cool stuff today. It's really cool, and you ought to explore it at some point, at some time if you can, but we're not going to do it now. Just understand that whenever we're doing things like updates, we are really returning new objects. And then I'm going to show you the really sexy one, update in. Update in takes an object and then a series of keys and drills through those keys arbitrarily deeply in a collection and then applies a function. So the use case for this particular update is probably not very well motivated, right? The US Postal Service has incremented all zip codes by 1. As a result, right, they needed to add one, like some really important city, right? You know, San Francisco won the World Series, and so they're going to take over a really low-numbered zip code as some sort of trophy, and so all the other zip codes have to get incremented by 1. I hope that we don't ever do this. But if you wanted to do something like that in this case, I could say go to Stu, drill into the address, drill into the zip, and inc, which is short for increment, what you get there. I like to show this because when people start doing this data-oriented style of programming, if they're coming from an OO perspective, they're used to creating a lot of extra plumbing and infrastructure at every level, right? If you're doing this in OO, how would you write this? You'd have a person class, and then what would address be? another class. And that would have the benefit of having a specific API that you could say, go to the person, go to the address, tell the address to update itself. And people, when they start using Clojure, they say, well, how do I do that? Right? If I'm not going to make classes for all these things, how do I get to that nested thing and do something to it? And this is one example. Now, let's go to records. I've now changed to use Clojure classes, def record person, def record address. What changed down here? What changed in accessing from generic maps to a specific record? Nothing. You go from data to objects. Does anybody in here at all practice what they would call Agile? Where you do something like, I'm going to build the simplest effing thing that works and then evolve it if I need to? This is magic if you care about that, right? Because you start your system saying, you know what, I'm going to presume Yagni. I don't need any classes. I don't need any records. I can just work with data. And if any piece of data ever gets painful enough that I really need to treat it as a record and add special services to it, then I can go back and do it. And what happens to the code that I've written so far? Nothing. This is really a terrific thing. Now, the second thing I'm going to talk about as regards Clojure's approach to OO is protocols. And I'm going to do this even more quickly. So a protocol, in this particular case, this is a protocol actually from Clojure itself. As file and as URL are functions that convert things to files and URLs. If you've worked in Java, you know that there are about a half dozen different kinds of things that are basically could be aliases for files or URLs. And if you work in a dynamic language, you really wish for some sort of magic that you could sprinkle over that and say, okay, I don't know if you pass me a string or a java.net.uri or an input stream or this or that or the other thing, but I want to treat it as a file if it's at all possible. So that's what these things do. This is a named set of generic functions. They're polymorphic on their argument, on their first argument, and they define functions in whatever namespace I'm working in. Right? This is where this is. What is this most like in Java? Let me ask that. Interfaces. But where do interfaces happen? When I actually go to implement an interface in my class, where does that implementation code go? In my class. Right? That implementation goes in my class. These things, the implementation code goes in these functions. It goes in as file and as URL. The dispatch is controlled by me and lives in these functions when I create this thing. So here's a very Java-looking example. I'm going to define a special record called name, which is just a wrapper for carrying names around. And it's going to implement the coercions protocol for files. And it's going to say, well, whenever you call as file, just call file and give me that back. And then I can say, give me the name John Doe, and as file that, I get back the file John Doe. This is not idiomatic Clojure code in this case. I wouldn't manufacture a special name record just to wrap names unless there were some other reasons in play that we can't see here. But this shows you a syntax that lets you do classes and protocols simultaneously. Right? Def record is like class. Coercions is like interface. And so this lets me do what I'm used to. The funny thing is that in a language that's class and interface based, this is often all you can do. Right? There's this presumption that when you sit down to write code, you have the classes and interfaces in hand, which is not very friendly to modification of the system later. Maybe you have the classes in hand now, but you're going to have the interfaces next month, or vice versa. So we can do that. Let me just say as file on data.text. Well, if I just sit there at the REPL and type that in, it's going to tell me java.lang.illegal argument exception, and there's a nice error message that I didn't repeat here, but it says, hey, that protocol as file does not have an implementation for the data type you passed in, which is what? A string. So I go back and say, oh, now it does. Extend protocol coercions. And now instead of saying an inline, just do an interface inside of a thing, I'm saying make the coercions protocol be available on nil. I just showed this to show you could do it. And make it be available on string. So this is the scenario where I just created the protocol and I want to extend it to a bunch of classes that already exist. You could also flip that around and say, let's say I just created a concrete class and I want to extend it to a bunch of protocols. So in this case, I'm extending string to coercions and string to equality partition. And so what you've seen here is the boring case where I do everything inline in one place. Right? I have a one-to-one correspondence. I do classes and interfaces, which is the traditional Java style. Or I can extend a protocol to multiple types. Or I can extend a type to multiple protocols. Or, I'll show you this one later, I can actually build all of this out of functions and maps. Right? There's a bottom API that I haven't showed you yet that would let me just do this by hand if I wanted to. And the important thing here is that the extension happens in the protocol functions, not in the types. Right? Nothing happened to string when I did that, right? Which would be a problem because I can't make anything happen in string. One last quick example of OO Clojure style, which is reify. Reify is a combination of anonymous class and Clojure. Clojure with an S, right? So this says reify some arbitrary protocol and give that thing access to something that's in lexical scope. So let x equals 42, let R be some unnamed class that implements the protocol, a protocol, and then has access to x. And this is not important for our conversation today, but I mention it for completeness because the name of the language is Clojure. And so it's nice to see that there's actually nice support for closures, and it's integrated with the support for OO, right? So you can make things that are objects, and they also close over stuff. Now, I've shown you all those Clojure features for making things. Records, which are like classes but represent an opinionated view of how to do classes. Protocols, which are like interfaces but represent an opinionated view about how to do that. I haven't showed you how to call this from Java, and I'm not going to spend a ton of time on this, but really briefly, if you want to compile a Clojure package, then you can say compile, name of the package, from the interactive REPL. That's great for interactive development, but you're probably going to be using some sort of unbelievably complex set of build tools and IDEs, and in that case, you're going to have some sort of manifest file that says what you want to compile. So here it says, I'd like to ahead of time compile examples.contacts. And there's support for this in Maven, in Leiningen, in Gradle, in Eclipse, in NetBeans, IDEA, Emacs, So all kind of the actual syntax I show here is from a tool called Leiningen. But I'm not going to give you the roadmap for your local tool set because there's kind of infinite variety here. But all these things eventually do is call compile. From a Clojure perspective, there's no requirement to ship compiled Clojure code. Clojure code is compiled as it's read, and it's incredibly fast. Right? So actually, for my day job at Relevance, most of the Clojure code we've shipped, we actually ship as source code. And it goes onto the deployment machine as source code, and you take microseconds of time when the application server starts up and it compiles the files as it sees them, and off we go. But if you're in a Java interop scenario, you're going to need to compile. Once you've compiled, calling this stuff is as boring as Java, right? Or as exciting as Java, right? So you can instantiate things with Java constructors. You can treat things as private data, person.fname, or you can do the more Clojure-ish thing and treat everything as maps. Right? Say, look, I've instantiated this thing, and oh, by the way, it's also a map. Yes?
Back on the previous slide, I just wanted to ask about something I saw. There was a single tick quote, and I wasn't sure if that was any special indicator for the package.
It is not a special indicator for the package. So examples.clojure is a symbol, which refers to a namespace. And so the default behavior when you see a symbol is to indirect through that symbol and find what's there. In this case, the namespace isn't there yet because we haven't compiled it. And so tick is... That single tick by itself is the Lisp idiom. It's actually kind of unappealing 50 years on, but it's the Lisp idiom for saying don't evaluate the next thing. Right? If you wanted to, you could write a version of compile that didn't have that tick in it, and that makes the thing look more like language syntax. Right? This doesn't look like language syntax. It looks like I'm reaching under the covers. And in fact, you are, in one level at least, kind of doing that. Oops. So there's another thing that you can do, which is generate a class full sauce. So at the top of a file, when you declare a namespace, you can say, I'd like this namespace to also have a class. And when you do that, you get access to all kinds of options that let you do things that Java might want when it talks to you. In particular, it lets you extend things. Closures, protocols, and records do not allow you to do implementation inheritance because we believe it's wrong. Gen class does allow you to do implementation inheritance because even though we believe it's wrong, you might need to do it because there's going to be some API that says this is how it works, and so you have to do it. And so you're going to see this in Clojure that there's a little bit of a bifurcation in the API. There's what we think is the best way to work, and then here's things you might have to do. And I'm not going to show you all the options for Gen class. I will point out that there's like 15 or 16 options to Gen class. And then there are conventions for how you map those to methods. And so in this particular case, this is a program that reads a build.xml file and spits out the list of targets. And this does it old school, right? We actually instantiate the sax parser, and we implement the start element method, and manufacture things. Gen class is for interop only. You would never, ever write a gen class if you were just trying to build something and do it well. The only purpose to ever go to gen class is there's something in Java that says, right, you're building a hybrid Java and Clojure system. There's something in Java that says you must do it this way, and gen class is the path to get that way. So gen class goes into dark alleys and meets Java, right, where it needs to get things done. But if you can get away with it, you would use def protocol, def record, reify, and def type. And the short summary here, and I think this is going to maybe be repeated in the other talks in terms of a lingua franca for talking between these JVM languages, right? The Clojure way of doing interop across JVM languages is stick to your interfaces. Right? If everything's done via interfaces, then all the languages can participate and nobody has to do weird contortions to make it work. Gen class does some of those contortions, but in general, I think the Java community would agree that's good design, right? Things should be built in terms of interfaces. This is an evolving truth, but I think that it's had 15 years to settle in at this point. I particularly want to say that the previous slides were examples only, that XML access in Clojure doesn't suck like that. It doesn't require you to get access to the Java plumbing. I just wanted to have an example because you're going to have your hairy company-specific API, which I couldn't have written for you. But the Java stuff has actually been written. So there's actually APIs for XML, and it might look something more like this. Read the HTML, select the target, grab the name attribute. Right? And you can make this as expressive as you want to using the XML APIs. So, where are we? We're done. You've seen the mechanics. Right? You've seen that Clojure can call Java. You've seen that Java can call Clojure. You've also seen that Clojure makes things better. It makes things better by making things more expressive. There are also a bunch of ways Clojure makes things better that we haven't had a chance to talk about today. And at the end of the day, so what? Right? How many languages on the JVM make things better than working in Java as of right now? Most, right? The number's probably in triple digits. Right? There are a lot of languages out there that are going to make your life better, and you're going to see a bunch of them today. So I'd like to spend the rest of the talk not talking about this stuff, not sort of establishing that there are languages that... Does everyone kind of believe that there are a bunch of languages that make life on Java better? Right? If you don't believe that, you're not going to be happy with the rest of this talk, or in fact with this track, right, I think. So, but if you do believe that, then what you're really interested in is, okay, how are things different? And the way things are different is that Clojure prioritizes simplicity. Well, that's a strong statement or a weak statement, depending on how you define simple. So let's do some defining. One possible definition of simplicity is related to the count of things. This is an actual quote from the Clojure mailing list. It was from somebody complaining that they had to do a lot of work to deploy a Hello World web app. And so the notion of simple here, and the actual thread title on the mailing list was simple things should be simple. The notion of simple is entirely based on how many steps you had to do something. How many lines of code? How many program text lines? How many boilerplate lines? Well, counting is not a good approach to simplicity, right? That's simple, even though it has a bunch of things. That's equally simple, even though it has more things in it. That ain't simple, right? The minute you start adding variation, things aren't simple. So the count of things is not a particularly good definition of simple. How about beginner-friendly? You see this a lot. Here's one of my favorite industry quotes in the past 10 years. The most important gauge of any programming language is how easily a novice programmer can maintain a significant program in any problem domain. This is such a great quote because you can translate it to anything. Right? The most important gauge of the San Francisco Giants playbook is how easily a high school athlete can participate in the World Series effectively. I mean, not a good definition. Also, there's a lot about simple to read, learn, and understand. I love this quote because it calls out PHP as a great example of simplicity, and this is C++ and Scala. Your mileage may vary. These definitions... What's that?
It's also self-recursive.
Yeah, I don't even get into it, right? Yes, simplicity should be simple. If you define everything about ease of learning, then it's going to be quite obvious what the best language is. And it's going to be quite obvious what the best musical instrument is, right? We're going to change the orchestra, have all the professional musicians play kazoos, because clearly that's the easiest thing to learn. Right? Easy to learn is a valuable thing for a hobby. It's not necessarily particularly appropriate for a career. Familiar syntax. This is a big one. Maybe simplicity means familiar syntax. So consistent with normal, average, non-mathematically trained brains. Maybe simplicity means minimal, right? So if the semantic model is simple and precise, less is more, we have a simple something. Maybe it means uncomplicated. I love this cartoon from Twitch. The top one is the typical Apple product. It has one button that does whatever is awesome in your world. The middle is Google. It has one thing that always finds stuff. And the bottom one is your app. Right? All of these things that we just talked about are valuable. They are to various degrees goals you would aspire to. Right? I would like things that I write to be convenient or noob-friendly or easy or have a familiar syntax or be minimal or uncomplicated. Those are all useful things. This is extremely important. Right? I am going to define simplicity from the dictionary objectively, which means that we're going to all have to step away from the associated value judgment. Right? Most of the time, simple is just used as an argumentation word to mean what? Approval. Right? This is simple, which means I like it. Right? I'm not going to use simple in that way, which means that when I say something simple, it's going to mean something particular, and none of these things here. And when I say something is complex or compound or complicated, all of those things have meanings too, and they're not necessarily insults. Right? So just as simplicity is not necessarily praise, these other words are not going to be insults. So people who are about to feel insulted, just take a deep breath. So is simplicity hopelessly subjective? Here's a great quote criticizing Martin Fowler, who's here at the conference. This is somebody who found refactoring not very appealing because their definition of simplicity was, well, Fowler's definition of simplicity, according to this person, is small methods, and his definition of simplicity was big methods. Don't give up. Simplicity has an objective definition. It informs design, particularly in Clojure, and in Clojure we believe it's fundamental. And simplicity means that. Check the dictionary. Simple means not compound. Right? And in fact, it actually comes from medicine. Right? Compounds are concoctions that people put together to treat diseases. And in order to put together those concoctions, they went out into the field and collected simples. It was actually a verb originally. You could go simpling. Right? I've got a bad cold. I'm going to go simple on the hill over there and see if I can find something that will make it better. And then I might find 3 or 4 things and compound them together. Java delivers compounds. Right? In fact, OO in general, as practiced today, is all about doing everything in one place. It's not simple at all. Objects provide methods, they provide polymorphism, they provide types, they provide namespaces, they provide structure, they provide mutation, whether controlled or not. Right? This is by definition not simple. It's putting everything together in one place. And in fact, you could come out of this and realize that POJO is an oxymoron. Right? There's nothing plain about a Java object. It's incredibly rich. It's chocolatey. It's tasty. It's delicious. It has a lot of good stuff in it, but it isn't plain. And so Java's style is compound, complex, and complicated. Features are delivered as compounds. Compounds contain more things than you need, and this snowballs from languages into lives. I'll give a metaphorical example again from medicine. Let's say that I suffer from anxiety attacks, and I go get some medicine that helps me with anxiety attacks. What's likely to happen? It's going to help me with anxiety attacks, but what else is it going to do? Something else. Usually more than, right? And you love those lists at the end of the commercials, right? This is going to cause, pupil dilation, restlessness, loss of appetite, increase of appetite, loss of sexual potency, increase of sexual potency, right? Like this huge list of other things to do. And if I have a really serious condition, if I really have to get condition A under control, I might end up doing what? Taking a second thing with compound effects to undo some of the compound effects of the first thing. And then I might take a third thing with compound effects to undo the effects of the first 2 things. And we actually have an expression in this, getting back to software design, we have an expression that talks about this. You start to settle out to solve one problem, but via a series of compound effects and interactions, you find yourself doing what? Yak shaving. You have a pair of clippers in your hand and you're shaving a yak, which had nothing to do with your original problem. And it's a direct consequence of enshrining compoundness as a good thing. Clojure delivers simples and composites made of simples. Right? And a composite has been composed together and can be taken apart, unlike a compound, which can't. So there's an important difference there. Right? We certainly don't want to say you can't build bigger things out of smaller things. It's going to be hard to do software development that way. And so all of Clojure's pieces that were stuck together on the Java picture are exposed individually. And I'm not going to go through all these pieces. You'll have the slides to look at later, but I am going to give examples. So the first one is polymorphism a la carte. Right? If I take polymorphism as a simple and deliver it as a simple, then I can do things like extend to existing types. What are my other options here? If I'm not going to be simple, what could I do? I could do wrapping, or duck punching, or monkey patching, or coercion. There are a bunch of other options that will solve this problem, but they are not simple. Now let's revisit the extension options in Clojure. Inline, extending types to a protocol, extending protocols to types, or building directly from functions and maps. That last one means that you have an implementation reuse strategy that's entirely built around your library for dealing with collections. Right? So if you wanted to write your own strategy for mix-in reuse in Clojure, first off, you could just do it. Right? This is an example of mix-in reuse. And the thing that's happening here is I'm using assoc, which is a function for maps, and I'm building on top of a set of default implementations, which is a map of keywords to functions. And so what this means is that, in general, whereas problems require a specific API to deal with your compound, if you're working with compounds, in Clojure you already have your simples in play. You've got maps, you've got functions, you've got keywords, and you can actually work with those things directly. If you want to make a higher level API for convenience, you can do that. It doesn't add simplicity, it actually subtracts from simplicity, but it could be convenient to have a higher level API. But you could actually build directly out of these things. And so you don't need a special library to build mix-ins. And you don't have to do mix-ins the same way I do. And we can both use the collections API to build it. Another example of simplicity comes in syntax, and I mentioned this before. It's singularity of interpretation. Right? When you're reading code as a programmer, your job is to understand what's going on, and that job is greatly simplified if everything in a particular context has a singular interpretation. In Lisp, it is the case that things that follow the parentheses are verbs, whether they are functions, operators, methods, calls, imports, metadata, control flow, or scopes. Right? If you take all of these things and make a special syntax for each one, that is not simple anymore. Because now it's a whole bunch of different things that you have to learn and meanings that are in context. Whereas here, you have one meaning in a given context. Right? After the open parentheses, I have a verb. One more example of that, which is bindings. So here I've got bindings as of arguments to a function, bindings in lexical scope, bindings in dynamic scope, bindings in a comprehension, bindings for side effect purposes, and all of those things have exactly the same syntax. Right? So when I see a context that can be bound, where names can be bound, that works the same way everywhere. Right? This is simplicity from a syntax point of view, having a single interpretation, not a compound interpretation that you have to break apart in your head. A third example that I'm going to show is generic data access. And I'm going to go very quickly through this example. Here we have a list of lunch companions. And those lunch companions are represented by maps. Neil, Stu, and Dan. Now, if you were taking a Java-ish approach to this, you might write a getter function for getting out pieces of those conceptual classes, right? If that was being written in an OO language, we'd make that a person class. And if it was going to be a person class, we'd have a getter function for last name. So here, define last name, get X last name. And then once we wrote that function, we could pass it to a higher order function. So now I could say sort by first name, which is a getter function, the lunch companions. I could also do that with an anonymous function. So I could say, hey, let's just have an anonymous function in line. This is not really worth giving a name and putting in a separate place. So I'm going to say sort by that anonymous function which does something to lunch companions. And I could even use a shorter syntax for that. And in fact, I could use an even shorter syntax for that. And in fact, I could use that syntax for that. But really, the end game is that. Every object that will ever be created in Clojure is accessible via this API. Even the Java objects, even the records and the protocols and all that stuff. Every object you create in a language that doesn't have generic data access is a private language that nobody else has yet. Now, think about this. If what I'm saying is true, and it is, right? If every new thing created a private language, then people would suffer from that, and then once they created a bunch of things in their own private languages, they would perceive pain, and then they would build Band-Aids for the problem. What would those Band-Aids be named? Design patterns, that's a global name for them. I agree with that. But in this case specifically, the fact that you don't have a generic data API, you'd have to go back and reinvent one on top of your system. And it would have names like reflection. It would have names like the Java Bean spec. It would have names like every data mapping API ever invented. Right? Not all of data mapping APIs is evil, right? But the part that just has to undo what's missing at the bottom is tragic. Right? The part of data mapping that's rediscovering universal data access. Right? And if you're coming at it from a Clojure mindset, you would definitely say that when people look at the object relational mismatch, right, you would find most of the fault on the object side of that divide. Right? The relational folks are actually trying to have a generic language, and the object folks are trying to have an opaque domain-specific language for every entity in the domain, and then they're frustrated that it doesn't work well with a generic thing. Now, simplicity is important, but there's one other goal in Clojure that is also important, and that is direct access to the JVM. Right? I like to divide languages in my mind into top languages and bottom languages. And top languages are concerned primarily, if they have to make a choice, with programmer experience. And bottom languages are concerned primarily, if forced to make a choice, with giving you access to the raw power that's available on your platform. The distinction clear? Now, does this mean that bottom languages that are really powerful have to have sucky experiences for developers? No. Does this mean that top languages can't be really performant? No. What it does mean that when push comes to shove, when you have to make hard choices, that a bottom language wants to give you power. Clojure is a bottom language for the JVM. Clojure was written to replace Java in day-to-day work. Right? It was not written to be more expressive for programmers. That is a wonderful side effect. Right? It was written to give you access to power. Living on the JVM is about getting performance, about getting power, and about getting reach, right? Getting access to all the libraries on the JVM. But it imposes a bunch of trade-offs on a language. You have to deal with primitive operations. Right? If you're really going to expose the power of the JVM, you can't just magically box everything and be done. Right? It gives you collection conformance issues, right? You have to conform to the Java collection API even where it's weak. You have to deal with the fact that there's no tail call optimization built into the JVM yet. You have to deal with a lot of OO interop odd points, like all the stuff that Gen class deals with in Clojure. And you have to have multiple numeric towers because Java does. Not because you want to deal with numbers that way, right? You want to discover God's truth about numbers and implement it. But if you're going to work on the JVM, you're going to also have to offer the JVM's truth about numbers, whatever that is. And so Clojure does all this. And I'm not going to have time to talk about all of this in detail, but it's going to be there in the slides. There is a set of operations for working directly with arrays, which are, as you know, mutable. There's a set of operations for converting between Clojure objects and arrays. There is Clojure syntax for doing unboxed math. So on the top here is a poor implementation of fib written only to demonstrate performance characteristics that runs dynamic languagey slow. And here's that same implementation of fib with type hints running Java fast. And where those type hints are used correctly, you will get equivalent performance to Java. And that's a big deal. Right? If you can't deliver the performance of Java, you're not going to be a bottom language. It's also worth noting, and this syntax is actually the way this works is the biggest change from Clojure 1.2, which is currently in release, to Clojure 1.3, which is currently in alpha. I'm showing you the syntax on alpha. The big thing that's changing is that in order to get that Java performance, you had to work hard and do ugly things. And it's changed now so that you get to do this, and you get type inference. Right? So I can say long in, and then type inference flows through the entire function. Clojure has to do explicit TCO with an explicit recur form because that's what the JVM gives us. The saving grace of having to do loop recur is that you actually don't have to do it very often. Right? 99% of times when a new Clojure programmer writes an explicit recursion, writes an explicit loop, they're doing something that could have been done by composing functions. So when you go back and look at this slide later, what you're going to see is there's the recur form, and here's 4 other forms that compose functions to do the same work. If you're going to live on the JVM, you're going to have to do annotations. Please stop, by the way. Annotations are bad. But if you're going to live on the JVM, you're going to have to support annotations, and so Clojure does. And it supports them by leveraging Clojure's maps. It's a wonderful example of having built a simple general-purpose thing in Clojure metadata. If you want to see how simplicity pays off in developer effort, go and look at the Clojure code for adding annotation support and compare it to annotation support in any other JVM language of your choice. It's a beautiful little piece of code that adds this support. Having said that, it's a beautiful little piece of code you should never avail yourself of unless you're forced to. Finally, the numeric options. I'm not going to go through this all in detail. I can take it up offline. I just want to point out that Java has its primitive stack and its big integer, big decimal stack, and Clojure reflects them so that you get access to those things if you need them. But Clojure gives you a numeric tower that's better than either of those, which is the default for everyday use in Clojure. Right? This is really important. Right? We have a numeric tower that beats the Java numeric tower for usability and matches it for performance in most cases. But we also have the Java numeric tower that you can go and get when you need it for performance. This is critical if you want to be a bottom language on the JVM. You've got to deliver the numeric tower. Do I have 5 minutes or 15? 5. So I'm going to end by giving a design example of a new feature that's been added to Clojure in the 1.3 alpha branch. And it's going to walk you through how you might think differently. I wish I had more than 5 minutes for this, but this is really important because there's a lot of stuff going on in Clojure that's novel if you're coming from Java anyway. And so a lot of times people come away dazed with the possibilities and they want to go and apply it. So this is that initiative. And this evolved from me saying this. When I'm sitting at the REPL and I'm holding on to something, I'd like to be able to reflect against it in a Java sense. Right? Most of the time, I don't want this because I'm just living in the world of doing Clojure stuff. But if I'm exploring a new API, right, I'm integrating with some existing Java library, I want to reflect against it. Why do I want to reflect against it instead of reading the Java docs? Who trusts the Java docs as God's truth on a subject? Right? Me neither. Right? I can say Javadoc, by the way. At the REPL, I can say Javadoc blap, and it just pops the Javadoc for anything. And I want to be able to use this on instances. I want to be able to use it on Clojure-y things, on Java-y things. All Clojure-y things are Java-y things, right, at the end of the day. But I want to be able to reflect against things. And there was already a function that sort of did this called REPL-utils show. And REPL-utils show is a thin, some people would call it a thin DSL-ish wrapper on top of Java reflection. And it allows you to say, show me the things on foo that start with the regular expression last. Right? So this says, go and get the last, so that's reflection, right? This will give me what I want at the REPL. The problem with this, from a Clojure perspective, is that Java reflection is deeply compound. It's not simple. It delivers a bunch of things all rolled together in one ball. It delivers query, right? How do I ask things? It delivers description. What are the things that come back? It delivers invocation. And, particularly interestingly, reflection in Java requires that I have the class in hand, right? Loaded in the JVM. It doesn't require much work to imagine a scenario where you have a class file that you want to find out something about, but you don't want to actually instantiate it in your JVM, even just for security reasons, right? Somebody just handed you this class file. And in particular, it has to be in the context of your class loader, right? So reflection is driven by the class loader. You actually have to have the object in your hand to reflect against it. And I don't want all of these things, or if I do want them, I want them as composites, not compounds. Right? I want to have these things one at a time. And so the approach in the reflection API in Clojure is that there's a single function called reflect, which takes a polymorphic helper called the reflector. And the reflector here is an implementation abstraction. It is not an abstraction that the user cares about at all, but it abstracts over different ways to reflect against Java stuff. The Java reflection API is one way. Does anybody know another? If you wanted to reflect against Java stuff without loading classes, what would you use? Some bytecode manipulating library. So you could plug in any bytecode manipulation library here and get access to it via the reflector. I want to wire this together, and I want to wire it to, in particular, queries. So I reflect against an object and get everything about it. And then I want to narrow that by a query. And then I want to wire that query to an output formatter that prints it in a pretty way when I'm working on an interactive Unix console that I can't get anything better than that. But the wiring I want to be generic. And so we already saw the thread first operator, the double greater than here is the thread last operator. These are generic wiring that lets me pass something to something to something. So I'm not going to write a custom piece of code to do that. Back through generic predicates. Right? What is the data going to come back from the reflector as? The world's worst thing it could come back as is a custom API, right? A java.lang.method object, and a java.lang.reflect.field object and a java.lang.reflect.constructor object. That would be not good, right? Because then it's a custom language. Getting that last little, the DSL-ish part, and a lot of people talk about DSLs as if that syntax part was the most important piece, right? It's an important piece, but it really is the top of the pyramid, right? You want to have your abstractions right so you're not writing a ton of code. I can put icing on top of this anytime I want to, right? But this is all built out of composable parts. And it beats the pants off of reflection APIs that I've seen elsewhere, which is not to say it's perfect. It's been through several iterations. It could stand to be improved more. Yep, we're at that point. So, I did not tell you how to use Clojure later this week. Right? That was the mission that was laid out for this track. Right? If you have the wrong definition of use, right? The definition of use that I think most people think of is putting jar files on their class paths and starting typing. I'm going to encourage you to take 3 steps back from that. Right? Using begins with thinking. Right? And what I want to have given you today is the ability to start thinking about things differently and also to know where Clojure might fit in your ecosystem. If you've read the Agile Manifesto, they say that certain things are prioritized over other things, which is not to say that the other things suck or are unimportant. I'm going to end with a similar message. Clojure is going to fit for you if you value simplicity and direct access to the JVM over everything else. Right? In particular, if you value it over convenience and familiarity. Right? But there are a lot of other design goals that you might have out there that I didn't even enumerate today. And in the Clojure world, we don't value those as highly. Right? So if you value something higher than simplicity and directness, then Clojure is not going to be a happy place for you. Right? If, on the other hand, simplicity and directness seem like pretty neat stuff, which they do to me, then you might find Clojure a very valuable place to be. And you might find Clojure's design style and reading some Clojure code and looking at how things are built as useful and instructive, even if you decide not to write code in Clojure. Right? So maybe you have a set of other goals and a set of other language drivers that don't let you go here. That's fine. My name is Stuart Halloway. I hope you've enjoyed this, and I will be available out in the hall to pick up the conversation and carry this further with anyone who's interested. Thank you.